Okay, so the images show a normal curve with a mean of 40 and a standard deviation of 2. The area under the curve to the left of 39 is 0.3085. The area under the curve to the left of 43 is 0.9332. Okay, so yesterday we were talking about this whole concept of z-score, right? This z-score table, and there's a positive one and there's a negative one. And this is going to help us find the area or the percentage that's underneath the curve. Now, since it's a normal curve, we know that the total is percentages that we've been learning about for the past week. You would get 1 or 100%. Okay, now the question says find the area under the curve to the right of 39. But we're given the information about the left of 39. So how do we get the right side of 39? Well, if we know that the total answer is 1, okay, total of the curve is 1, then we're going to take 1, should give us to the right of 39. So if I go into my calculator and I say 1 minus 0.3085, that's going to give me 0.6915. Okay? Or another way to say this is 69% is over here. That's in the pink. Now, if we want to find the area under the curve between these two numbers, and they give us both of those informations, then what we're going to do is we're going to take 0.9332 and subtract 0.3085. Those numbers both came from this information right here. So I'm going to go into my calculator, and I'm going to subtract, and that's going to give me 0.6247. Okay? Pause. Wait a minute. Okay, so now it says find the area under the curve to the left of 40. Well, remember that 40 is our mean, right? 40 is our mean. So if the mean is 40 and we want to find the area under the left, to the left of 40, that's going to be 0.5. Okay, the reason why I know that is because if the mean is in the middle, then that's half of your data is to the left, right? Find the area under the curve between 39 and 40. Okay, so if we know that this is the area under the curve, and we know that 0.5 is the area for 40, then what we're going to do is just subtract those two. And when we do that, we're going to get 0.1915. Alright, so a survey indicates that people who use their computer on average 2.4 years before upgrading to a new machine. The standard deviation is 0.5 year, and assume that the variable x is normally distributed. So draw and label a curve. Okay, so first thing what we're going to do, draw this awesome curve. In the middle, we're going to put our mean, which is 2.4, and then we're going to add our standard deviation, which is 0.5, and then we're going to add our standard deviation, and then we're going to add our standard deviation, and I'm going to do it one more time just because, and 4.4 over here. Okay, and then we're going to subtract our standard deviation, and subtract our standard deviation, and subtract our standard deviation. And we can do it one more time if you want to, but up to you. Okay, and for my sake, I always go in and I write in the numbers just so that I'm on the right track. Like, I want to make sure I don't mess anything up, right? So 13.5, 15.5, 2.35, 2.35, and then we got 0.15 chilling out here. Okay. And again, this is that information that we learned last week. So if you weren't here, you didn't pay attention or whatever, you got some work to do. Okay, so we've done that. If a computer owner is selected at random, find the probability that he or she will use it for less than 2 years before upgrading. Okay, now 2 years is not on our normal distribution. Like, it's not like one of the numbers that's listed here. So yesterday we talked about how we had x minus mu divided by sigma would find our z, right? Remember, x was our point, so this would be 2. Our mu is going to be our average, which is 2.4. And then our standard deviation is going to be 0.5. Okay, so we're going to plug in. And then we're going to subtract and then divide, which is going to give us negative 0.8. Okay, so now we're going to actually talk about a z-score table. So what you would do is you would just open up Google and you would say negative, since our z-score is negative, z-score table. Okay, I'm also going to post both of these so that you have access to them. You want to look for a negative one. You don't want to look for a positive one, though. Okay, so you're looking for these negative numbers right here. Okay, so I'm just going to use this. Ooh. Okay, so looking at this, what's going to happen, I'm going to clear this really quick and then I'll put the numbers back. Okay, so we want negative 0.8. So we're going to start here where it says z. We're going to go down to negative 0.8. And there was no number after the fact, right? So it was negative 0.80. So we're going to go over to where it says O. And that's going to be this number right here. So that 0.21186. 0.21186. So 0.21186, right? So that means that it's less than 2 years, right? So that's from like here and below, right? That's going to be 21%, 21.2%, right? And that seems about right. If we added up all of this that we already know, it's going to be roughly around 20, right? Okay, so that's how you convert from a z-score to a probability. Okay, so let's go ahead and look at the next one. So on part B, he or she will use it for more than 3 years before upgrading. More than 3 years. Okay, so first of all, it's not on our normal distribution, so we're going to have to use the formula. So that's going to be 3 minus 2.4 divided by 0.5. And remember, those are the numbers that I got up above. So 3 minus 2.4 divided by 0.5, which is going to give me 1.2. Now, this is a positive z-score. So I'm going to go in. Okay, give me 1 second. I'm going to go in. I'm going to type positive z-score table. And you can do images or you can just like pull up one of these. And that's a negative. That's positive. Good. Okay, so now we need 1.2. And I'll bring back that stuff in just 1 second. 1.2. So we're going to go down to 1.2 and over to 0 because that's the next number over, right? So 1.2 to here. So that's 0.8849. So let's go back to our thing. That's 0.8849. However, they said more than 3 years. Okay? With z-score tables, they always read left up to that number. Okay, so they kind of essentially calculate this information, which is why this percentage is going to be so high. But we want more than 3 years, so we want the stuff that's on the right-hand side. So instead of 0.88, we're going to do 1 minus 0.8849. 1 minus 0.88849 is going to give you 0.1151, which is going to turn into 11.51%. Okay, so if they ever say more than, that's when you're going to use that 1 minus. Right, so that he or she will use it between 1 and 2 years before upgrading. So, again, this is not on the normal distribution curve, so I'm going to have to calculate it. So I'm going to do 1 minus 2.4 divided by 0.5. And I'm also going to have to do 2 minus 2.4 divided by 0.5. And the reason why I'm having to do both is because I'm trying to find it between those 2 years. Okay, so I'm going to do 1 minus 2.4 divided by 0.5, which is going to give me negative 2.8. And 2 minus 2.4 divided by 0.5, which is going to give me negative 0.8. Okay, so what you're going to do is go to your z-score table, pull both of those probabilities, and then you're going to subtract them. So we're going to go to our negative z-score table, okay, which is right here. We're going to go down to negative 2.8, so on the left-hand side, negative 2.8, which is going to be 0.0026, okay, and over here this is negative 0.8, so that's going to be 0.2119. Okay, going back to my page. Okay, and then now I'm actually going to subtract those two numbers. Okay, so I'll take 0.2119 and I'll subtract 0.0026. And that's going to give me a difference of 0.2093. So there's a 20.9% that they'll use it between 1 and 2 years before upgrading. Okay, so looking at this problem, these are the two normal distribution curves that you should have gotten. Again, I would always make sure that you label your percentages in there just to make it easier on yourself. It doesn't have to be a perfect curve. Obviously, you can see what my curve looks like. But that being said, you do need to write this out every single time. Okay, so coming down here, you decide to take both tests. You score an 1875 on the GRE and then a 57 on the MAT. On which test did you score better? Okay, so what we essentially have to do is find the z-score, convert it to the probability, and that's going to be your overall test score, right? So I'm going to go ahead and start with this one. So that would be an 1875 minus 1500, and then my standard deviation is going to be 300. So I would do 1875 minus 1500 divided by 300, and that's going to give me 1.25. I'm going to go ahead and calculate this one too. 57 minus 50 divided by standard deviation of 5. So it's going to be 7 divided by 5, which is going to give us a 1.4. Okay. And then we want to go into our positive z-score table because both of these numbers are positive. We go down to 1.25. So we go down to 1.2 and we go over to 0.05, which is going to be at 89.44. So 89.44%. And then we want 1.4. So we're going to go down all the way to 1.4. That's going to be a 91.92%. So coming back here, which one did they score better on? They scored better on the MAT. So on part B, this is what you should have gotten. Remember, you're going to have to round to the nearest hundredths because otherwise what's going to happen is you're going to have some wonky answers. So we're going to go in and we're going to look at our positive z-score table. We're going to look for 0.92. So we're coming down here, 0.9 going over to 0.02. So that's going to give me 0.8212. 0.8212. Okay. And then the other one is 0.8, so we're going to go down, and that's going to be 0.78.8.